I'm going to be working section 2.4 circles, starting out with number 7. And it is giving you some information here. You have a circle with a with a radius of 6 units and a center of 3, -5. And so now what we're going to do is try and pick which equation is the correct representation of the circle. And all we're going to be using is the formula, the general formula for a circle. So there's your formula. The point HK is the center, and then of course R is the radius. All right, so this is just plug and chug. We're going to replace H with 3, we're going to replace K with -5, we're going to replace R with 6. So I'll do that up here. We're going to have X minus 3 squared plus, now be a little careful here, Y minus -5, right, because it's -5. Y minus -5 is actually Y plus 5, quantity squared, and then equals the radius 6 squared, which is 36. So that looks like that is choice D. And that's it. Now we're going to move on to, oh, there it goes. Okay, we're going to move on to number 9. So find the center and the radius of each circle, write in standard form. Okay, so they give you a picture for number 9. So I'll do my best to draw this picture. Okay, number 9. So they give you two points, 0, 1, and 2, 1, and they give you this circle, goes around like that, something like that. So they want to know the center and the radius, and then the standard form, the standard equation. So the center is obvious, it's our HK, in this case is 2, 1. And then for a radius, all we have to do is find the distance from the center out to any point on the circle, which this point right here would be perfect. So we just need to know this measurement, and it's obvious that this is 2 units. So, and that's because the y coordinate of both of these is 1, so these are the same height, which means we can just go look at the horizontal distance from here to here, which is 2. So my radius here is 2. So the standard form is x minus h, here h is 2, squared, plus y minus k, which is 1, squared, equals my radius 2 squared, which is 4. So there's my center, that's my radius, that's my standard equation. All right, moving on to number 13. Man, they must have sprayed for bugs in here because it stinks. All right, so now they give you for number 13 a radius of 2, and they give you HK is equal to the point 0, 0. And they want to write the standard equation in the general form equation for each circle of radius r centered at HK. So let's see what the difference is here. The standard form, x minus h squared plus y minus k squared equals r squared. The difference between the standard form and the general form is that with the general form, we're going to expand out these squared quantities. So let's first just replace things here. H is 0, k is 0, so this becomes x squared plus y squared equals 4. because we're squaring 2. And that's our standard form. Now the general form would be to square both of these. But since they're single terms here, there's nothing to square. So this is actually both the standard form and the general form. So the same answer for both. Now on number 15, it'll be a little different. For number 15, the difference here is that it's 0, 2. Let me just double check that. And the radius is 2, 0, 2. So the only thing that changes here is that this is still x squared, because there's a 0 there, but then plus y minus 2 squared equals 4. So this is our standard form. The general form, we're just going to expand this. So this is one answer, standard form. I'll just say standard form, SF. And then the general form, we square this. So that means we're going to get y squared minus 4y plus 4 equals 4. So I just had to FOIL that out. And then now I need to get this number on the other side so that all my x's and y's are over here and all my numbers or constants are on this side. When I subtract 4 and subtract 4, I get 0 on the right side. And this would be our general form. GF, general form. All right, number 21, same instructions, but they give you that your radius is a half and your HK, your center, is 1/2 0. Yep. All right, so let's plug some stuff in here. Man, this is really not good. All right, so we're going to plug in our center, x minus 1/2 squared, plus y minus 0 squared is just y squared, and then equals 1/2 squared is 1/4, because it's 1/2 times 1/2. So that is our standard form. Now the general form will expand this out, so I'm going to multiply this times itself. For this one, I think I'll actually write it down so you can see a little more of the detail. So I'm going to FOIL this out. So we get x squared, then we get minus 1/2 x, minus another 1/2 x, and then negative 1/2 times negative 1/2 is positive 1/4, plus y squared equals 1/4. And then I'm going to get all my x terms together, y terms all on the left side, and then I'll take any constants to the right. So I'm going to have to subtract 1/4 on both sides. When I subtract 1/4 on both sides, it goes away. So I'm going to have a 0 on the right. And on the left, notice I can put these two together. So we get x squared. If you take negative 1/2 minus 1/2, that's negative 1. So negative 1x. And then I still had plus y squared equals 0. So there's our general form. There's our standard form. All right, number 23. I am recording, right? Okay. 23. All right, here they give us an equation. We want to find the center and the radius and then graph it and find the intercepts, if there are any. So x squared plus y squared equals 4. All right, so what we need to see here is that this really looks like x minus 0 squared plus y minus 0 squared equals 2 squared. So my center is 0, 0, and my radius is 2. All right. So anytime we see x squared and y squared by themselves without any x's and y's, linear x's and y's, then this is always centered at the origin. All right. So now I want to draw it, right? Find the center, find the radius, got that. Graph the circle. Centered at 0, 0. Radius of 2, so I'm going to go out 2, that's a point. Up 2, that's a point. Left 2, that's a point. Down 2, that's a point. Draw my little circle through here. This is a very basic circle. And so I have x-intercepts. It hits here, which is 2, 0. Hits here, negative 2, 0. Y-intercepts hit here and here, so that's at 0, 2, and 0, negative 2. Yep, okay, that's all they wanted there. That was kind of not that interesting. Let's look at number 25. So we have 2, and then x minus 3 squared, and then plus 2 y squared equals 8. All right, so we need to make this look like standard form first, and it's not in standard form right now. The reason is because we have these coefficients out here, 2 and 2. That's no good. So let's divide everything through by 2 first. So I'm going to divide every term, both sides of the equation, by 2 to kill off these 2's. So if I divide this by 2, this by 2, this by 2, I'm going to get x minus 3 squared plus y squared equals 4. Now that looks like our standard form. Remember, this is y minus 0 squared. So I'll write it down. And 4 is 2 squared. So I've got my center is 3, 0. And then my radius is 2. So when I draw this, I'm centered at 1, 2, 3, 0. There's my center. And a radius of 2 means I go to the left 2, go to the right 2, that's 5, go up 2, down 2, like that. I have x-intercepts, this point right here, which is 1, 0, this point right here, which is 5, 0. And then in terms of y-intercepts, you can see that I never hit the y-axis. So, none. All right, 27. Now we're getting something interesting. X squared plus y squared minus 2x minus 4y minus 4 equals 0. So here is the first problem that when we're trying to get this into standard form, we have not only our x squared and y squareds, but we also have some x and y terms. So what we're going to do in order to get it to look like the standard form is we're going to try and complete the square. So I'm going to first group up my x terms, things with x's. Then I'm going to group up the things with y's. And I'm actually going to move my constant to the other side. And now what we do is we tackle these piece by piece. So I'm going to take these two and work with those. So what I do to complete the square is I take the number in front of the x, which is negative 2, and I take half of it, always. So I divide by 2, and this gives me negative 1. Okay, that's one of my numbers I'm going to use. And then what I do is I take that answer, negative 1, and I square it, and I get 1. This is my second kind of magic number. So then we come back here, and we write down x squared minus 2x, and then what we do is next to the 2x, I use this number right here, and I'm going to add it and subtract it. Add 1, subtract 1. Actually, I wanted to do that in blue, so you could see it came from there. I don't even know if the blue will come up out on camera. Add it and subtract it. Then we're going to do these two. We're going to take the number in front of the y, which is negative 4. We will take half of it, always half, which is going to be negative 2. That's our first number that we're going to need. And then take that negative 2 and square it, and that gives us 4. That's our second number. So what we do now is we write down plus y squared minus 4y. Then using this number right here, I'm going to add it and subtract it. So add 4 minus 4. And then continue writing the equation. So we've rewritten this equals 4. All right. And now, if you do it correctly, right, and use the appropriate numbers, these first three terms are a perfect square trinomial, which means it's guaranteed to factor to be something like this, squared with x here. And you could just figure it out by looking at it, but if you don't know what it is, you just go back to this number right here. Not the second one that we used to add and subtract, this one right here. So this would be minus 1 in here. And then don't forget, we still have minus 1. And then these three terms, again, factor out to be plus y and then something squared. And the thing that goes here is this number, minus 2, goes in there. Okay? And then we still have a minus 4 here, equals 4. I'm almost there. I just need to move these constants over. So I'm going to add 1 over here and then add 4. Or you could say I'm going to add 5 to both sides. When I add 5 to both sides, I get x minus 1 squared plus y minus 2 squared equals 9. And there's my standard form. I can see from this standard form that my center is the point 1, 2, and my radius is 3, because 9 is 3 squared. And now I'm going to draw it. I'm out 1, up 2. There's my center. My radius is 3, so I would go 1, 2, 3 here, 1, 2, 3 here, 1, 2, 3 here, and then 1, 2, 3 there. So it goes like this, and there it is. Now I have x-intercepts, and I have y-intercepts. But these are not as obvious. You can't just look at them and get them. So to find the x-intercepts, we're going to have to do a little more algebra. All right, so I'm going to leave my standard form down here. To find the x-intercepts, we do what we always did back in college algebra. We set y equal to 0 in this equation. So if I set y equal to 0, let's see what I get. This doesn't change. So I still have y minus 1 squared. And then if I let this be 0, 0 minus 2 is negative 2. And then square that, that's 4. So I'm going to get plus 4 equals 9. Now I subtract 9 from both sides. Subtract 4 from both sides and get 5. Now I take the square root on both sides. And when I do that, over here I get x minus 1. Over here I get plus or minus square root of 5. And then finally, I will add 1 to both sides. You get x is equal to 1 plus or minus root 5. So this is really two answers. 1 plus root 5, 1 minus root 5. And the square root of 5 is about 2 point something. So 1 plus 2 point something is about 3 point something. So it's not a very good picture here, but 1, 2, this is 2, this is 3. So you can see that one of the x-intercepts is a little bit past 3. So it makes sense. This is going to be 1 take away a little more than 2. So it's going to be negative 1 point something, and that kind of matches it. So it makes sense. We could get those as decimals, but I'm going to leave them as exact answers. And to write them correctly, since they're x-intercepts, we should put 1 plus root 5, comma 0, and then 1 minus root 5, comma 0. Those are our x-intercepts. To find the y-intercepts, we do kind of the reverse. We're going to set x to 0. I'm going to do it over here. For the y-intercepts, set x to 0 in the equation right here. So if x is 0, you get negative 1, you square it, you get 1. 1 plus, now this doesn't change, y minus 2 squared equals 9. Subtract 1 on both sides. Take the square root. Remember, we're going to have plus or minus root 8. And then add 2. So 2 plus root 8 and 2 minus root 8. So write these as ordered pairs. You get 0, 2 plus root 8, and then 0, 2 minus root 8. So let's see, square root of 8, it's close to 3, but it's not quite. So it's 2 point something. So 2 plus 2 point something is about 4 point something. And it's kind of, you can kind of see it from here. 1, 2, 3, 4 point something. That's where one of our y-intercepts are. And then the other one is down here. So that's it. Okay, 31. Looks like another good problem. X squared plus y squared. Kind of disappointed that none of our centers have had a plus in the formula. I was really hoping to get one of those. I think we're going to get one here. All right. So this is the same story. We need to collect all our x terms and y terms together. And get the constant to the other side. That should be minus 1. Okay, on the first two here, I'm going to take the number in front of x, which is negative 1. I'm going to divide it by 2. Ooh, that's just going to give me negative 1/2. Okay, then I'm going to take that negative 1/2 and I'm going to square it, and that's going to give me 1/4. So I'm going to be adding and subtracting 1/4. Okay, so x squared minus x, just write that down. Add and subtract 1/4. Then plus y squared plus 2y. Now we take the number in front of y, which is 2, right? We divide it by 2 and you get 1. That's nice because when we square 1, we get 1. So our magic number here, they're both the same. So I'm going to add and subtract 1 here. And then I still had their equals negative 1. So I'm going to move this out of here. Equals negative 1. Now the first three terms here should factor perfect square trinomial. It'll be x and then something squared, and I just erased it, but it was negative 1/2 there. So negative 1/2 goes here. And then we still have minus 1/4 plus, now these three terms are going to factor to be y plus 1 squared, that's using this number. Then I still have a minus 1. And on the other side, I still have equals negative 1. Okay, good. Now let's move things around here. Add a fourth and add 1. So add 1 over here and you get 0. Add a fourth, you get 1/4. So you should have 1/4 on the right side. On the left side, x minus 1/2 squared plus y plus 1 squared. All right, we have a slightly more interesting problem here. The center is 1/2 negative 1. Be very careful here. Minus 1/2, remember in the formula it's a minus, so you're just going to take the 1/2. Here it's a plus, but in the formula it's a minus, so you have to say minus minus. That means it's a negative 1. So that's our center. Our radius, be careful here, is 1/2 because this is our radius squared. So that means our radius had to be 1/2. Let me try and graph this. It's nauseating, the smell in this place right now. What is it, these bags? I don't know. All right, so I'm going to go out, let's say this is 1. I'm going to go out 1/2 and go down 1. 1/2 and down 1. There we go. And then our radius is 1/2. So here's 1/2, here's 1/2, 1/2. So it's just going to go like this, right there. Looks like we don't have any x-intercepts, and it looks like we might have one y-intercept. Now we could check this pretty quickly, and I'm going to do something a little bit tricky here. Instead of instead of finding the x-intercepts by plugging in y equals 0 here, I'm going to go back to the original one. And it'll be much easier to work with, all right? So if I want the x-intercepts, we should not have any, but let's see why. Let's replace everything here, all the y's with 0. So you get x squared minus x plus 1 equals 0. And that's a quadratic equation. And if you try and use the quadratic formula, you should get a negative under the root. Let's just do it real quick. X is equal to negative b, which is the opposite of this, so 1 plus or minus the square root of b squared, which is 1, minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. So if you do this in here, you're going to get 1 minus 4, that's negative 3, and the square root of negative 3, that's an imaginary number. So there's no real solution here, which corresponds to the fact that we have no x-intercepts. Now, if we want to find the y-intercept, we're going to replace x with 0. So this is gone and this is gone. So we have y squared plus 2y plus 1 equals 0. And this right here is a perfect square trinomial again. It factors. And then you take square root on both sides, you still get 0. When you take square root of 0 here, you get 0. And then subtract 1, you get y is negative 1. So the y-intercept is 0, negative 1. That's the only one we have. 0, negative 1 is that point right there. Works out. All right. 39, last one. Is it the last one? Yeah. Short homework assignment here. All right, find the standard form of the equation of the circle with the center of 2, 3. Okay, so they give us the center is 2, 3. I'll draw it real quick. And is tangent to the x-axis. So here's our x-axis, and it's tangent to that, which means that the circle, when we draw it, should just touch this x-axis here. So it should, go something like this. And that's a key to the problem because the only thing we're missing to write the standard form is the radius. But we know that the radius here should be the distance from the center, the vertical distance from the center to that x-axis, which is 3 units. So the radius is 3. That means that the standard equation is this. Okay, our center, 2, 3, radius squared. We're done.